Welcome once again to Amazing Maths Pro channel. So this is question of the day. This exponential equation 3 to the power a plus 9 to the power a equals 27 to the power a. So let's see how we can solve this particular equation here for the value of a. So we can write all these one to have the base of a. So first of all, let's write 3 to the power a plus 3 squared. Remember, 9 is the same as 3 to the power 2 equal to 27, which is equally 3 to the power 3, and then we attach our a. Now let's express these ones in terms of 3a so that we can have a common expression somewhere. So we can have our 3a here plus 3a and then squared equals 3a once again, and then cube. Now let 3a equal to a single variable x. By so doing, then we can write this as x plus s squared equal to s cubed. Now we can rewrite this equation here to have s cubed minus s squared minus x equal to 0. Then x is common to both sides, so let's bring x out. So you have left with s squared minus x minus 1 equal to 0. So when you compare, we can see that already we have one of the roots equal to 0, and then the quadratic root, which is s squared minus x minus 1 equals 0. So let's see if you can solve the quadratic part. But when we look at the coefficients carefully, we cannot have any clear-cut root. So we're going to use the quadratic formula x is equal to negative b plus or minus the root of b squared minus 4ac all over 2 of a. Knowing very well that our values of a is going to be 1, b is -1, and c is going to be -1. Therefore, we can write s is equal to -1 minus of that plus or minus the root of b squared, which is -1 squared minus 4, a is 1 and c is -1. Then all divided by 1. And then eventually this is what you're going to have. You're going to have s is equal to 1 plus or minus root 5 over 2. So we have these two values here. So plus of this or minus of that. But let's remember that we still have another x value here, which is 0. We have another x value here, which is 0. Okay, so we have these three roots, which is x equal to 0, x equal to 1 minus root 5 over 2, and then we also have s is equal to 1 plus root 5 on 2. So these are the three roots that we have gotten. These are the three roots that we have gotten. So what we're going to do is that already we've said that let our x is equal to 3a. So in effect, we can say that 3a equal to 0, 3 to the power a equal to 1 minus root 5 over 2, and then also 3a equals to 1 plus root 5 over 2. Great. All right, so looking at the nature of these equations here, we have to apply the idea of logarithm. Yes, so when you take the log to both sides, so log 3 to the power a equal to log 0. And then also we have log 3 to the power a equal to 1 minus root 5 over 2. And then also have the log of that. Okay, and then we also have the last one, which is the log of 3 to the power a equal to the log of 1 plus root 5 over 2. But you realize that we don't have the log of 0. We don't have the log of 0, so it will be taken out. There is nothing like that. And then this expression here will give us negative. And since the log of a negative expression does not exist, that one too is off. It cannot be a solution. So the only one that we have left is this. Remember, we can write this a here according to the laws of logarithm to be a log 3 equal to the log of 1 plus root 5 out of 2. So eventually have a is going to be log 1 plus over 2 divided by the log of 3. So when you simplify this one, you are going to get 0.438 to 3 decimal places. You're going to have this as your final answer. A is going to be 0.438 approximately as your final answer. Thank you very much for watching, and please don't forget to subscribe to our channel.